There we go. So the app is running. All it's doing is every request that comes to the root route, it will just return a JSON representation of two things: host name and the network. So that's what you're seeing here. The host name is Cypher SMBP, and then the network that I'm on is 192.168.50.51. That's all it is. So what we're going to do is we're going to Dockerize this application. Now, to be able to run this application, right now it just so happens that I've got Node installed on my machine. Okay, so if you write node-v, they will show it print to you the version of the node that's currently installed on my host machine. So if you're going to Dockerize this application, what does that mean? That means to create a Docker image that encapsulates the very essence of your application and the operating system that it needs to run, and you encapsulate all that into one Docker image. So to be able to get started with doing that, I'm going to introduce to you the first of two magical Docker files that you're going to need. Okay, the first one is Docker file. A Docker file is the blueprint that tells Docker how to build the Docker image out of your application. The Docker image is what you use to start Docker containers. Okay, what does a Docker file look like? More important than giving you the fish today, it's important also to teach you how to fish. So Docker file example, you can just whack out, just whack Google. Okay, create a file name Docker file in the same folder, blah blah blah. So this is what we'll need. We can copy paste first. Okay, so Node 12 Alpine is fine. You do npm install. Npm install. Okay, all right. So what's going to happen is I'll break it down for you line by line. So Docker, you're saying, you know how I mentioned that when you're shipping a Dockerized application, you are shipping an application together with the operating system that it needs to run. So the world of Docker is it's layered. You build upon the images that are already provided. They are already freely available on Docker Hub. What is Docker Hub? Docker Hub. Node. Node. There you go. And what's all this? These are just the tags that this particular image supports. So this is the image. This is the name of the base image. The tags are what you use to supply the version. So what I'm behind this is the version of the node image. That's what we're using. So if I were to read this in plain English, right, it is just I hereby declare that I would like to create a Docker image. I would like to work off the good work of others who have already done Node version 14.17 Alpine. And the next after that, I would like to create a new directory inside the container called slash at the location /source/app. And I would like to declare the working directory to be. In fact, we don't need this as a distraction. The next thing I want to run is that I want to copy the package.json that I have on my host machine over here, the Docker context, and I would like to copy it at this location inside the image. Okay, so remember earlier we created a folder, and then now we are copying the contents of that we have outside in the real world. We are going to copy it into the Docker image at this position. And then the moment I have the package.json in there, I will run npm install so that I can actually fetch the dependencies. Now, what dependencies? It's just inside your package.json is this one and this one. I want to pull in two different dependencies. That's it. And after that, I will copy. In fact, this one is not necessary. Yes, it is necessary because we are going to copy the entire folder, the entire Docker context, which is this entire folder, this entire sample node app folder. And we're going to copy it into the position as /app, and then we're going to expose the port 3000, and last but not least, we're going to run this command. Okay, so this is important. When you cd into, right now, where am I? I'm located at this particular position, but note that our node applications is inside a folder below, so we do need to go down one level. And once you see the Docker file, okay, you're in a good place. So that's what we're going to build it now. Hey, wait, how's my terminal? Is it legible for you guys?
Yeah,
Yep,
you
it's
can
legible.
you can type command plus to actually make it bigger. Yeah.
It doesn't work, so I got to use the command scroll. Okay, there we go. So second, the first Docker command that you'll need to know is how to build that image based on the Docker file that you just declared. Okay, so before we do that, I'm going to teach you the second command, Docker image ls for list. Doing this, you will see all the images that are currently present inside my computer already. But what we're going to do is, after I create the Docker image, the name will appear, a new image will appear here. Okay, so that's what I'm going to do. So this is the command Docker build. We're going to give it a tag. -t, we're going to call it sample node app. Okay, sample node app. It has no relation to the name of the folder. So in fact, you can name it whatever you want. My node app. Yeah, my node app. And then you want to tag it latest, or maybe you want to tag it version 1, let's say v1. And the last one, this is important, just press dot. Because the last one represents the context that you need to supply Docker. Okay, you want me to build, so Docker is asking you want me to build an image, but based on what? Based on what folder? So the dash dot is that's what you're telling Docker lah. So let's do that. If you already have the image in your Docker image ls, then you don't have to download it. Obviously, I got it very quickly because I already have the image inside my machine. But if the first time you're running it on your machine, there will be a Docker pool. They will download from Docker is intelligent enough to download the image from Docker Hub. So what are these 1, 2, 3, 4, 5? They correspond to the number of lines that affect layers inside the Docker file. So let's go through it one by one. Step number 1, from this particular base image. Number 2, I will make the directory. This is the second command. Then step 3, I will copy the package of JSON to that location. Step number 4, I will run npm install. And step number 5, I copy source app into that position. Expose and CMD don't affect layers, so they're not part of the build image. So let's clear this. Docker image ls, and then you'll see at the very top, you'll see my node app. The new image has just been created with the tag v1, and the image is blah blah blah. The rest doesn't matter. 55 seconds ago, and that little computer I said, right? I said that every Docker image outlined is like a blueprint that ships the operating system as well as your application. Okay, so that's your entire application and the operating system. So let's run this. How do we run this? This is the second command, the important command. Docker run. Docker run. I want to give it a name so that it's easy. Docker run my node app. We need to expose the port. So -p, maybe I'll expose it on port 8080. More on that later. And I will map it to port 3000 of the application. And if I reflect it like so, Docker. Package this one. Package we need the worker. Okay, let's build the image again. Okay, so now okay, so what happened was you need to tell Docker when you're building at build time, you need to tell them that you need to set the work directory to be this one, so that when that Docker knows, it's like you're controlling the CD, change directory, change directory, change directory. You're controlling it inside the container. So let's
Bro, just one question, bro.
Go ahead.
Yeah, just the /src/app, right? That's the Docker's, the OS, right?
The inside the image. We will sort of SSH. We will possess our running container after we run it. Okay, so I'll show you. So what's happening here is, okay, I'll break it down. I'm running a container. I'm running this image and this tag. Okay, and I'm exposing the port 8080 of my host machine. I am exposing that port, and I'm latching it onto the container's port 3000. Remember, every running container is like its own computer with its own set of doors, all 65,536 of them. So this syntax here means that on the left is host, on the right is image or container. Host container, that's the convention. So when I run on 3000, okay, guess. Since I'm running on port 8080, if I go to my browser and I type localhost 3000, will I get something? If I refresh this, will I get something? No, because it's no longer running. So there's nobody listening on port number 3000 anymore because I've mapped it to port 8080. So that's what's happened. Maybe PP80 was a bad idea. Dstop all, demove all. See, Docker run 8080. Let's make it 8000. Okay, 8000. Confirm no clash. Run -p. Okay, 3000. There we go.
Can we run both on the same ports?
What do you mean?
Like your host computer, you run 3000, your Docker image, you run 3000.
You can, because they are totally different. So in fact, that should be, in fact, as a learner, I should show you that first. then introduce to you what the mappings is. So I've stopped my container, and I'm going to start it again. And you get to see my 8,000 is no longer answering. And there you
Sorry,
go.
I'm following your steps. And how do I stop the Docker?
Okay, so how do you stop the Docker? It's just Control C and as you would to kill anything that's conquering your app. Conquering your terminal. I've already taught you Docker image ls to list the number of images that you have inside. Now to see the running containers inside your machine, Docker ps-a. Docker ps will only show you containers which are running. It will not show you stopped containers. -a will show you everything, including stopped containers. Okay, so on my machine, you can see that I have two containers that have previously run. They were running the image MyNode app with the tag v1, and they were both exited already. That's how you stop.
So if mine has like one that's up for 4 minutes, how do I kill it?
Okay, so you see this? Just copy it, double click on the container ID, copy it, Docker, stop, debugger. That's it.
You don't even have to put the whole ID, right? Like the first few digits is enough.
Oh, is it? I've never tried that.
Yeah.
Oh,
But, yeah, it will match.
Cool.
I see.
Thanks.
Okay. Remove. So I've got aliases to sort of clean up my environment lah. So dstop all is literally just Docker stop all running containers. Remove all is literally just remove all stop containers. So that's what no stop service going on there. No, okay. So if you've got no running containers, the moment you do that, it just stops. So your one running container, which was previously latched on to 3,000, it just stops. And that's it really. You've successfully Dockerized one Node.js app. Now, what if this was a Spring Boot application, a Java application, right? Essentially. So there are base images for that as well. So there are base images already available on Docker registry that comes pre-packed with the JVM, the Java virtual machine already there. And there are similar images for PHP, similar images for Ruby. So if you're talking about Dockerizing your backend application, yeah, you just need to only Google and figure out what people do already and look at the base images that are already available for you to inherit.
I have a question.
Go ahead.
In your Docker file, right, what's the difference between command or the line 5 and the last line? The run npm install and command line. Yeah.
Okay. Command is the final instruction that your Docker container. So when you start a new Docker container based on an image, right, or whatever image that you already built, you need to the command line is kind of like the last instruction they run. So remember on our local just now, if you want to test locally, build locally, test locally, what command do I write? I run this command, right? npm start, right? And when I run this,
Yeah.
I'm running the entire application. So okay, full breakdown. When I run npm start, I'm going knows to go to the package.json, look for the scripts, look for a start script, and then run this command. So that's what it's actually doing. So that's why that is I want this exact same thing to be done inside the running container. Now for this run, this is the step-by-step instructions that you need to tell Docker what to do. So so like I said earlier, right, from this base image, create a new directory at this location, set the working directory to be this location, copy my file from my host over to this to the containers at this location, and then once you have the package.json already, immediately run npm install because you want to install the dependencies.
Run is during the build step, and cmd is the
Yes.
first command you run when you start the image.
I have a question. So at line 4, you're copying the package.json to the from host to the image, right?
Mhm.
And then at line 6 also, you're copying everything from the host to the SRC app, right?
Yes.
So can we just copy everything?
That's a good point. That's a good point. You can. So the short answer is you can. Let's test that.
Okay.
So I need to rejig because I need to make sure that I copy first, right, before I run the npm install. I need to make sure that the npm the thing is there. Docker build.
Oh, sorry.
Docker build. Okay, there we go. And this will work instead. This will also work. A Docker run dash b 3000 3000. Run it again. 3000 over here. There you go. there you go. That's it. We've dockerized the first of our Node.js apps. Now give me a second to let me see on my notes. Okay, so remember in the sample in the repo, the final repo, we actually have I want to teach you another fine point of what do you do if you want to access files, you want to mount files to the running container. So let's say I create a new file here called using.txt. Oh, it's already there. Okay, this is already here. Hello, generic user. Okay, great. So now, in my response, rather than just returning a JSON, I'm going to return a new key called file content, and I'm going to fs.read file sync dot slash. That's there. So let's build it. Let's build it locally first. No Docker needed. npm start. 3000. Okay, so now the file content need to string. Okay, up again. Crash. Okay. So as you can see, this is reading the file contents on the project directory and returning as part of the API content, API response. So we've modified the application, the core application we've modified, right? Okay, pop quiz. If I were to immediately run again, will I see the new changes that I've seen?
No.
Awesome, exactly. So if I were to run naively as is right now, and I'm wondering, hey, why this one not working? Why's my new change? It's because I haven't built yet. So remember, every time you make a change to the application, you need to inform, you need to update the image. So let's do the build step. And let's run that. And when you refresh, file contents there. Okay. Now I'm going to showcase to you the next important bit, the next important functionality. What if I want to mount something from something custom? So that means when you build an image, you build it and then you distribute it. But let's say someone who wants to use your image wants to run a container, but they want to supply their own file. So rather than your hello generic user, maybe they want to have hello Halik, let's say. So let's simulate that. So let's say there is a file that you want to overwrite the file that is being read. So you call it greeting custom.txt and inside it hello. Okay. Now how would you override it? How would you do this? So we know from the running container. Okay, let's do this. .dc. Dc is my alias for this. .dc again. D docker ps-a. Oh, I stopped my container. Start it again. 3000. Now, next command, very important, very useful command for troubleshooting stuff. Let's say you want to dive into the running container. So, you got your docker ps-a, it lists all the running containers. You've got this container, it's already running for the last 9 seconds. Now, what if you want to SSH into it to be able to see to see inside? So this is what you do. Another very useful command. Docker execute exec -it, and then you copy paste the container that you want, and then the last part, the bit is the command that you want to run to be able to assume to go inside the container. So usually it's sh shell. So you want to run, sometimes if you use a different kind of image, sometimes bash is available to you, but by and large usually shell will work, will exist. If it's Linux, they all generally do that. So once you do this, right, you're now inside your running container. So that means if I were to notice this, guys, notice this, the command prompt has changed. So if I were to run pwd to find out where I am, okay, I'm at that location. If I were to list where am I at, so see, I am at that location because the command that you gave, that's what it controls. So when you SSH into the machine, the running container, you will be spit out at the location. ls-al will list all the files. And you've seen greeting.txt. So if I were to cat the contents of greeting.txt when I'm inside the container, I will see hello generic user. Okay. So now I'm going to exit out of this container. I'm going to stop the running container. Stop you. Then I'm going to rerun it, but this time around, I'm going to mount a new volume. This is called Docker. I'm introducing you a new mechanism called Docker volumes, where you can mount something from the outside to replace a location inside. So the syntax is as such: /. No, it needs to be absolute path addressing. So pwd / greeting custom .txt, and you're mounting it at the location /src/app/. So what am I doing here? I am telling that I hereby would like to run a container based on this image and this tag, exposing this port 3000, my host 3000 to the containers 3000, and I would like to mount this file to override that file inside the container. That's what's happening here. So let's do that. Now I switch over to the other terminal. If I were to docker exec into the running container again, which has changed to docker ps-a, up 7 seconds. Let's possess it again. Docker exec IP. If I were to go inside it, ls-al, if I were to cat greeting.txt, since I'm mounting it, right? I'm mounting the new volume, I get the new version. Hello Khalik. So I'll repeat again. Note that when you SSH into the running container, when you cat greeting.txt, the file is still greeting.txt. Nothing has changed. The file name is still the same, because when we ran the command, we are mounting a new file, our own file, and then we are mounting it at that particular file. So it kind of overrides that particular file in that location. And since our application is always reading the file at greeting.txt, that's why it just works.
If you edit the custom greeting, do you need to restart the container, or will it update?
Yeah, because the way you run it is you're mounting it as a volume, you will auto update. So let's do that. So let's say you cat greeting x is still the same. It's still hello Halik. So you go over here, and let's say Halik and Aziz. Ta-da! So think of it as the magical
It's like a
enchantment
symbolic
away.
thing, is it?
Yes, exactly. So what are the typical use cases for this? Okay, back when I was working on PHP, which is an interpreted language, right? It's not a compiled language. This is very useful because I back then, once I discovered Docker, I didn't want to pollute my host machine with PHP runtime installations and all that jazz. So I'd rather just run a container, container with a PHP runtime inside it, and then I would mount my entire project files as a volume onto the running container, such that I can be comfortably editing the source code files on my IDE, which exists on my host. So I can write code over here, and I can automatically go back to my this one and just press refresh, because it will always load my latest edits. So that's the beauty. This is one very typical application of mounting a volume like this.
So for one question, if you change the content inside the container, will it change? I mean, the update will be reflected in the host.
So you mean to say if you were to SSH inside, let's say what kind of content?
I mean, this let's say this greeting.txt, you change it to something else inside the container. So will it change in the host also?
So meaning to say it's like VI, I start changing server.js, is it?
No, maybe greeting.txt.
Yes, it will. It's oh yeah, okay. Okay, actually that's interesting. Let me see. Vi, so no, greeting.txt. Let's delete you. Oh, alamak. Shit. I need Damn.
It's not here.
insert. Okay. Masih okay.
Oh no, we're gonna be stuck.
Oh no, I cannot exit. Oh no. WQ. No.
You need to press escape first.
Need to press escape first.
Yeah.
Well, that's just manual
WQ.
lah.
Okay, sweet.
Oh.
Okay, exit. Okay, WQ. Okay, sweet. So let's go over here. Ta-da! It updated.
Okay, alright. Thanks.
It's a two-way street, guy.
Two-way binding, they call it.
Yes.
Does
So
it actually? So it lives on a host machine lah, right?
the file.
Right. Yeah.
Yeah. So such that if I were to kill the container, your file still persists.
Okay. So actually, can you mount the whole like server.js also as a volume? Then it will update live? So no.
Yes, but then
Then you
remember.
need to restart the server lah.
Yes, correct.
Okay.
Which is not a big deal, right? I mean, we can
Mhm.
change it. We can change it, and then we can stop the container and start the container again. Remember I told you there is that command that you can do docker ps. Okay, let's say you do this, and you've got this particular one. You can docker stop the container, and then it will stop it. And then you can start it again. And because it's a Node.js, right? Hopefully it will pick up your changes, because it's restarting.
Yeah.
When you restart it, then it will pick up your code changes inside.
So you wouldn't need to rebuild the image lah, right?
Yes, correct.
That's the only difference, right?
Correct. So that's it for Dockerizing the.
Oh, I have another question. Sorry. So sometimes I use an image where they would create files in my host machine, right? And then the ownership of the file, the folder, right? It's owned by the host machine, is it? By the container itself, right? So how do I deal with that kind of thing, like?
Wait, Chop, the container is creating. It has no business creating.
No, because if it's a
mounted volume.
yeah, and then it wrote the files, it will own the files also, right?
But if you stop the container, I believe you still have it, because the app inside the container that's writing new files to that particular mounted volume, you
Yeah.
will have it. It's a two-way street, ma.
Yeah, you write it on the host machine, but then the permissions are off. It's quite annoying. Even like, for example, the database, right? The data mounted, right? So that one is on the host machine, but its permissions are I cannot even view. I need to sudo.
I see. That's a good one. I'll exploit it one day.
So the best practice is to run as rootless Docker, so that you will run as the Docker will run as the account that's running this container. If your account is the one that's running the container, obviously you have access to it. If not, by default, Docker runs as root. That's why you can do a lot of these things.
Oh, I see. So by default, it's run as root. Is it as root?
So if you look at Docker's actual documentation, right, there's something called rootless Docker.
So that's the correct way to do it, is it, or what?
Recommended way lah. For security reasons, also that's what we recommend.
So when in doubt, right, guys, you can always refer to best practices. So you can go to Docker Hub, you can click on any particular tag, and you can literally see the Docker file that they use. But yeah, you always know that it's there, that you can see the contents of other people's Docker files, even the ones that you get off Docker registry. Yeah. Okay, so let's move on. The next thing that we're going to do is we're going to augment our Node.js app to be able to talk to a running DB. Now, I don't have Postgres installed on my host, never, ever since I discovered Docker, because I just up a Postgres database container for this. So let's do that. But before we do that, it's time to introduce to you Docker Compose. So far we've worked with Docker, and Docker, the base Docker, lets you build images. You've already seen that from the Docker file. And you know Docker build command and Docker run command to be able to build and run your containers, build your images, and then run containers out of those images. So there exists another tool called Docker Compose, very, very nifty tool that lets you codify all those commands that you would otherwise type when you run Docker run. So all that stuff, it lets you codify it, and it lets you in one command up multiple containers at one shot, and have networking amongst those containers. That's the key point. So I've done this so often that I've got snippets, live templates in my IDE for it. So I'm going to strip it down a little bit so that you can. Okay, so let's say you're naive. Let's do this naively. Let's say you don't want MySQL, you want Postgres. What will you do? Go to Docker Hub, search for the image that you want. Postgres official image. Click on that. So let's say I want. So what's available, right? So let's go to the description. So what's latest? The latest is 13.3. Okay, so is there an Alpine version? 13.3 Alpine. Okay, good enough. Was that what I'm doing? Is that what I'm using inside the sample report I give to you guys? Give me a sec. 13.3. Okay, let's use that one. Let's use this exact same one. So Docker Compose YAML. Teaching you how to fish, you could just go to Docker Compose sample as the compose. You can try that if you get lucky. No, that's useless. Docker Compose and Django. Oh, that looks interesting. There we go. See, it's a YAML, so indentations matter. This particular Docker Compose YAML file declares two services. That's the language they use. Services. Each one of these is a service. And there's a DB service and there's a web service. So we are going to do just that. So let's go back to Docker, the Postgres container. Let's go and read the instructions. Now, this Docker Hub page is very important, guys. When it's usually well established images will tell you, will include instructions on how to get going with their image. So how to start a Postgres instance, you can just run this. So what are the environment variables that you need to pass? You need Postgres password as an environment variable to pass in, Postgres user, Postgres DB, and Postgres initdb. So before we get ahead of ourselves, let's just naively do it. Let's just do it the non-Docker Compose way. Let's do it the Docker run way, okay, as we've already been showing so far. So what I'm going to do is I'm going to run a single container, Postgres container, using 13.3. Let's use 13.3. And the password is let's say secret. And the Postgres user, I need another environment, right? For Postgres user. How come you didn't ask me? So confident. Okay, let's do that. So what is dash E? That's new. Dash E is environment variable. You're passing a new environment. That's all it is. So I want to call this test. And another last environment is the name of the schema, the DB that you want. So let's use that as well. Dash E. Oh, sorry. Dash E Postgres DB equals foobar. Okay, we don't care, right? Dash D is detached mode. Let's keep it attached. Docker run. So once again, Docker run. I'm giving a name, some Postgres. In fact, that's a distraction also. We can just remove that. So I hereby would like to run a Postgres in the container using Postgres image version, the tag 13.3, supplying these three environment variables. That's what
What's
we
the
do.
detach or attach? Is it something important for us to know?
Yes, it is. So I will show you now with attach first. So attach, once I run it, if I stop this, if I kill this terminal, my container dies. That's what attach means. You're literally just running it is. So that means if I were to open a new machine, a new terminal, I docker stop all. No, remove all stock containers. Okay, that's what I'm doing. If I will docker ps -a, I will see one instance, right? And if I were the moment I press cancel on this, the container dies. Cancel this,
Oh, okay.
the container dies. So if you don't want that, if you want to just start and then carry on my merry way, you detach. So from now on, we should be using detached. Okay. So let's do that. So dash D. Detach means I start and then I go on my merry way. That's what if you've got people who are quite new to or quite uncomfortable working with CLI, right? Another pro tip: you can run Docker dash. Generally, any utility in the Linux world will have this dash dash help. So Docker dash dash help, and you can get help about the base Docker command. Now, like I said earlier, right? Docker run is one of the very common command that you run. So if you want help specifically to run, you just Docker run dash dash help. That will list to you all the commands pertaining to run. So if you want all the commands pertaining to build, you docker build dash dash help. And then it will give you all the help pertaining to build. Very, very useful. I'm teaching you this because in the beginning, when I started my journey, CLI was such a scary thing for me. There's nothing scary to it. I'm showing you live, taking pains to show you why, because it gives you a lot of confidence when you can self-help on the fly. So, okay, let's continue. Let's list the running container. So I'm running in detached mode, so it's always there. And if you don't supply a name, right, to your container, they will give it a randomized name like this, romantic pike. So you can do this ad nauseum, by the way. So notice that I didn't attach any port. So that means if I were to run this again, yeah, the Docker is quite happy to start another container for me. And they'll give it a random name. Crazy, right? So I can do this ad nauseum. So literally, when I do this 5 times, I just started 5 little computers inside my computer, and they're all running Postgres. And you notice they start so fast. They start within less than 5 seconds, less than 10 seconds. It's already started. So if I were to stop or remove, then if I were to, so the new thing I want to introduce to you guys is the dash name equals dash name Postgres. Let's do this. And from now on, that's how you control the name. Again, to know what flags are available for you to play with, just Docker help. Just run dash dash help. And if I were to run this again, it will complain because there is already a container name with that name. See, it's complaining. Conflict. Container name, blah, 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 is already. Okay, so now that we've got a running container, so I've got on my computer Postbird, which is a GUI client for connecting to Postgres. So when we ran it, what was the instructions that we gave? User is test, DB is foobar, password is secret. Okay, let's connect using that. Let's just create a new one. Localhost. This won't work. Any guesses why this won't work? If I were to type 5432 now, username, everything's sweet, everything's sweet already, but it still won't work. Anyone want to guess why?
No point exposed.
I'm not exposing the port yet. So if I were to test connection, nobody's answering. Connection is refused because nothing's listening. So to fix this problem, docker stop Postgres. Since you have a name now, you can use it. Docker remove Postgres. Is it remove or rm? Let's figure out. Oh, yeah, it's RM. So Docker RM Postgres. Okay, you're good. So now if I were to just double confirm, yep, the port is no longer there. And if I were to run that command again, this time around exposing the port, -p. So let's say I want the same port. -p 5432 is the standard Postgres port. So let's just be unimaginative about it and expose the port. So once I do this and I run it, docker ps-a, start for 1 second. If I test connection now, it will work. So let's review a bit. What command line flags have you worked with? There is -v, mounting a volume, -e, supplying an environment variable, -p, which is exposing a port onto your host machine. And these are important things. So if I were to test connection, it's okay already, and I were to connect, then ta-da, you've got your database, a fully fledged, fully functioning database. Okay, I'll pause here. Any questions now about running this one-off using Docker run? Questions?
When you kill a container, the data will also die, right?
Yes, unless
Okay,
you
volume.
use volume. Unless you use volume, that's where this part comes in. This part actually volumes is you need to mount it. You need to create a volume and you need to mount it.
But you can do it. Can you do it in this command line also? Like like -v also here.
Okay, so what are the various entities in the world of Docker? So you know that there's image, right? Docker image ls to see all the image. Okay, you know that there is container, right? ps-a, so you can see containers. There is also a concept of Docker volume ls. Then you can see all the running volumes. Because especially for databases, the data that you insert in there, you want it to live on, right? Even after you dispose of the containers. That's where volumes come in. You need to create a Docker volume. You need to mount that volume onto your running container. Kill the container, the volume still lives on. Yeah. Oh, I just realized. Yeah, there is no connection between this DB data and DB simply because my workshop files does not go as far as writing SQL statements. Okay, but it's a distraction right now. Okay, so you've got your DB image, and now we want to litmus test that. We remember our Dockerized backend app already. Our Dockerized backend app. We want to have it in play as well inside a Docker Compose. So this is where we begin Docker Compose. Before I even bring in that one, let's change as little as possible between each test. So let's stop this container first. Docker stop Postgres. Now I'm going to introduce to you Docker Compose YAML. Make sure that you are at the particular folder with the Docker Compose YAML. So ls-l. Yep, I see my Docker Compose. Next important command, Docker Compose up -d is detached. Okay, let's play with it attached first. Okay, so when I run this, it will look for a file called Docker Compose. Let's delete this distraction for now. You will look for a file called default. This is the default file name. You can always rename it anything you want. You just have to supply another flag, the command line. So when you run Docker Compose up, Docker Compose looks for a file called docker-compose.yaml and knows what to do with it if you follow the format. So this particular Docker Compose YAML will up one instance of DB. So that's what it's going to do now. Since we're running it attached, it will conquer the terminal for you. So you can't shake out of it. So if I were to go to another terminal and just docker ps-a, true enough, we see the new workshop docker 101-actual db1. So Docker Compose even gives the default name for the container for you. All right. So kill you, and I run back this again. Yep. It's exited. That's the one. So now we're going to bring in our backend, our Dockerized backend application, the one that's using our sample node app, right? What name do we use, guys? Docker image ls. We were using my node app. Let's copy that. So now I am declaring a second service called backend. I'm using the latest version, but there is no different tag. So use v1. And I am mounting it to port 3000. And I'm telling that don't up this service until this service is up. So that's what depends on is. And let's add new code to our server.js to basically the database connection code. So let's do that. I'm just going to cheat a little bit and refer to my already done stuff. I need the async function.
So, can I confirm? So they need to run the DB instance first before they can run the backend instance. When you write that particular
Depends on,
syntax.
yes, depends on, correct. Let's review one line by line. So what's happening here is I'm starting and this we are back in our Node.js app, I guess. What we're doing here is I am okay, this one, ignore this one. This is basically when I'm running on my host, the network interface is available at this location. But if I'm running it as a Docker container, it is a different network interface. So that's why it's still a bit as well. So when I run this app, it will try and connect to the database using these credentials. Okay, so since I made application changes, I need to rebuild this particular node app image again. I need to be in the actual location. So sample node app. App. Okay, sweet. Docker build dash t sample node app. Is it my node app? I know that. That's what I call it latest. My node app latest. Dot. So over here, it's already built. And if I were to change it to latest, and let's up. So let's up my Docker compose. So Docker compose up. Let's see if there's any error. npm error, compile log. Okay, so something is off. Module not found. PG. Okay. So okay, great. So that means what's happening here is since I copy pasted code right from the already prepared repo, this module is missing. So I do need to run npm install so that it appears inside my package.json as a dependency. So let's do that. So sample node app is here, npm I pg. PG is Postgres, the client. So make sure it appears here. Okay, we're all good. Now we can Docker build again. Docker build dash t my node app latest. Dot. We build it again. Give it a chance to npm install the PG. And then now we can stop the Docker compose and start it again. Ta-da, we're good. So listening on port 3000. Let's stop and examine this for a bit. So if I were to run docker ps-a, it will show that I've got two containers related to our Docker compose. Let's remove this guy and this guy. Docker ps-a. Okay, so no pollution. So we have mapped port 3000. We have mounted. We have we have exposed port 3000 of our host machine to the backend containers 3000. So if I were to visit 3000 on my local, I should see new stuff. So generic user is back because we didn't mount it as a volume. And date time string, where am I getting that from? So date time string is coming from this location, connect to database. Connect to database is an asynchronous function which basically just connects to the database. The moment it does, it runs this SQL statement, select now. So select now is literally just the response that you get if you were to run reconnect. Go where you connect. Localhost that's 5.32 local. Okay, what? Why is it complaining? Oh, I know why. Guess why, guys? Why is it that my UI cannot? So do you see my DB exposing any ports? Don't have, right? So I didn't. I didn't expose the port. That's why. So let's do that.
So it's actually only available to the backend service lah.
The internal Docker Compose network. So we will play with this for a little bit. So let's say server.js. Note that what is the host that I'm connecting to? DB. Note that it's not localhost. Where is DB coming from? That's magical, right? Part of Docker Compose magical networking magic is that each service is resolvable with a DNS name equivalent to the name of the service. So if backend, the code inside backend, the app, right, the Node app, if it wants to connect to the database, the Postgres instance over here, it just needs to connect to this as a host, and it will automatically appear. So literally, if you just name this foobar, and then over there in that app you call it foobar, yeah, it will resolve. So that's the key point.
You need to update the yang depends on to line 8.
If you need to because you change the name.
Okay.
So now that I am exposing 5432, it can be any port, no guys. Just now I was trying 65535. So let's just do that for the sake of science, right? So I'm exposing DB, I'm exposing port 65535 to my to my container, my Docker, my Postgres container. Oh yeah, I've stopped your Docker Compose up. So what's the opposite if you want to bring it down? Dah tu je. Dah itu je. Docker compose ps-a, nothing is running. Docker ps-a, nothing is running. Okay, great. So now I'm going to up it again. Docker compose up, attached. Let's go attached. So server is listening. Port 3000. DB is also exposed. So how do I tell that? You can tell that by just docker ps-a. You can tell that even my Postgres instance is exposing port 65535 of my host machine to the containers 5432. So if I were to go back to my GUI, my database GUI, instead of 5432, I put 65535 and connect. Ta-da! I'm in. And when I run query, go all the way down, select this particular line, press one selection. That's what's happening here. So that's what you get here. The datetime string is literally just the ISO representation of datetime.
One question, sorry. Is there a difference between like Docker PSA and Docker Compose LS?
Docker Compose, when you Docker PS, Docker Compose PS, Docker Compose PS will only mind its own business. So what that means is when you run Docker Compose, it will navigate into the entire directory looking for Docker Compose YAML, and it will only list the ones that are pertinent to it. Yeah, so kirakan less noise. Docker PS, Docker Compose PS will only list that. So if I were to start your own container somewhere, let's say you're running 2 different Docker Compose, as long as you're not clashing ports, you can run infinite number of Docker Compose on your machine as much as your specs can take lah. So if you run Docker Compose PS, it will just list the containers pertaining to that. Go ahead.
If the Docker Compose command, right, basically looks for the Docker Compose YAML in the current directory, right? And then the up and down also depends on that file, right? So down, it will look for that file.
Yes.
So what happens if you up and then you deleted the repo, right? How do you down?
At the end of the day, they're just Docker instances, Docker containers. You can
So
stop
you have
it
to one
using
by one clear it out lah.
I thought you were gonna ask this question. So if you were to Docker compose up based on this compose YAML, and it's already up, and let's say you edited the code and I deleted this one. Right? So what will happen if I Docker compose down now? Interesting, eh?
Would it just be based on the new one? It should
Yeah,
be, right?
so I have a feeling you only down DB, but look at this, what's going on? Everyone moving network, blah blah blah, actually got ID has active endpoints. Huh. Well, that's interesting. But basically, yeah, that's a thing lah. You need to be wary of editing files. So let's make sure. You see the Node app stayed up. Node app stayed up because this Docker compose down. You looked for this file and you realize that backend doesn't exist anymore. So it strictly honored the file. So let's restore back. So Docker stop this one and remove all. So now I have a clean slate. Now, how might we complete this into a full stack? So we're going to do that real quick now. Let's navigate upwards. I'm going to create React app on the fly. So npx create React app sample React app. Go.
Question.
Go ahead.
So this React app, do you create this in your host machine or the Docker container?
Good question. So when I ran it, am I running it in the terminal? And this terminal is running on my host, kan?
Yeah.
So it's running on your host. The files exist on your host. Because I didn't SSH, I didn't run it. Look where I'm at. So your terminal will always tell you where you are. I'm right now inside your MVP. So npx create React app will create it where you run it. So as you can see over here, you can already see the sample create React app. So let's cd into it. Cd sample React app. Okay, let's close everything. Let's open the package.json. Okay, what scripts what they give us? They give us npm yarn start, so we can yarn start. So you see a yarn.log, they're using yarn, so let's just honor that. Yarn start. Cool. So localhost 3000, when this loads. So this is to the uninitiated, this is how you roll a new React app if you are using Create React App, which is the official tooling for bootstrapping a new React application. All React apps, if you're using CRA, it compiles down to static files, which means just simple HTML, CSS, JavaScript files. And when the web development world says that they are static files, is because they are not dynamic. What that means is that the content will always remain the same. And this, we say this with great significance because static contents can be served differently. There are various ways that you can architecturally optimize how you serve out static content as opposed to dynamic content. Static content can be cached by the world's content delivery network, the CDN. So literally, you can serve your compiled React app out of GitHub pages, out of anywhere, any static site lah. And how might we serve it out? So remember, I said that it's just React apps compiled down to static files. Static files means you can serve it out of any web server. The go-to in the world of web servers for Docker at least is Nginx. It's our familiar friend. So we're going to be augmenting our Docker Compose with a new service called Web, and we're going to serve it out. Let's imagine this is our done app, and we're going to ship this to production. Okay. Let's just kill this guy. And when it's killed, you can tell it's no longer answering. Okay. So, yarn build. That's the command that they give you if you want to build a production build. Now eyes on this, eyes on this part. When I run yarn build over here, once it's done, a new folder called build will appear over here. Okay. So yarn build. Okay, done. That's it. So if I click here, the build folder just appeared, and these are the flat files. They're nothing more than just files that any web server can capably serve. Now, how might you serve this in a production setting? Let's say, so imagine we introduce a new service. We are going to run it on our own custom image. So if it's our own custom image, what do you need? You need a Docker file. So let's go to our React app. Let's create a new file here, because we are going to tell Docker how to create our image. I would do it, but I've already done it over here, so I'm just going to cheat here. Simple. It's a 3-liner, guys. So let's break it down. Aziz, you want to try? What is this 3 lines doing?
So the first one is you build off the Nginx image, and then you copy the build file.
The folder, yeah.
Into that directory.
Mm-hmm.
Oh, it's Nginx HTML. And then your default Nginx, do you even have that?
Yeah, I don't have that. So literally, I'm just doing this. I'm creating a custom image. So much of my custom image is just one extra line, and I'm copying the build folder, the one that was the package for production, right? Getting ready for production. I just copy to that particular default location. So if I don't have this, what happens? Let's say I do this, and we're good. So okay, I need to expose the port. Don't forget. Let's expose the port. So let's say I want to expose port 80 to the Nginx port 80. Okay, just like that. Okay. You see, okay, Docker compose, Docker compose up dash D. I'm going to run in detached mode now. So now I'm going to do it detached. Then you might wondering, okay, detached all well and good, but what if I actually want to see the logs of my Docker compose? Okay, a new command now, guys. New command. So clear cd node app, get out dash out Docker compose logs. Docker compose logs will list the logs. But the thing is, it will list it and then end. So if you wanted to follow and maintain and track, how do you help? Just go to help. There is dash F here. Follow log output. So literally do that dash F, follow dash F, and it will always show that particular logs and follow it. So let's review again. I've got Nginx. It is running on port 80 by default. I'm not doing anything yet. Another pro tip, guys, browsers are defaulted to port 80 if you just type. If it's HTTPS, then it will default to port 443. So the whole time just now today, we've been doing this, right? We've been manually typing the port. But if you omit it, the world understands that you mean port 80 or port 443, depending on whether it's HTTP or HTTPS. So even if I wanted to possibly put 80 there, browsers will just omit it. It is understood, it's a convention. Okay, so this is the default container. This is the default file that Nginx serves. So remember, I told you let's exercise some of our muscles earlier. We've already learned how to SSH into a running container, right? So let's do that. Oh wait, let's list it first. Docker compose ps. I've got web. This is the guy I want. So I take this one, copy Docker exec -it, the container that you want to possess, and then sh. So I'm there now. So when I press refresh, welcome to Nginx. So let's make it welcome to MSOCIETY. Okay. So let's find where the file is located. /var. No. Okay. So etc Nginx.
Can I ask what the PS stand for?
Process is a Linux thing.
Oh, it's a Linux. Okay, can process.
It's a Linux thing. Process. I mean, why not Docker container, right? Docker container ls. Yeah, it's a holdover from the Linux world. User share nginx HTML. User share nginx HTML. cd/user share nginx cd HTML. So these are the files. There's the 50x.html and index.html. So if I were to vi index.html, oh no, it's vi again. Okay, let's try this without looking like a complete retard. Okay. Oh shit! Baru cakap. Fix it.
Oh no. GG.
Escape.
Just
Escape.
Yeah. Press escape.
Okay. Okay, sweet.
escape.
Press escape. I press colon WQ. Okay, is it my changes there? Okay, my change is there. Okay, sweet. Okay, now since it's a web server, right? My change inside the container will actually it doesn't. Why doesn't it change? Is it even this file that's being served, or is it being cached?
Yeah, you can try hard refresh maybe.
Yeah.
Oh, there's a title. You change the title. You didn't change the.
HTML v6.
Yeah. Yeah, there below there, the H1.
Master. Sorry, I'm so used to my IDE. Didn't see this. Okay. There you go. Escape. Oh, sorry. I.
Or just use Nano next time.
It cannot. Okay, that's the thing. I would have. I love Nano. I would have, but then the base image that we're using doesn't have Nano in.
Oh, GG.
Yes. Okay, this is very important. It's a good lesson, good teaching moment. Because when you're running containers in production, you want the absolute leanest OS layers possible. So that's why if you don't need Nano in there, don't pack Nano in there. So that's why people love Alpine. Some people love Alpine because it's the flavor of OS which is as thin as it gets. So that's why you want very lightweight containers. So that's done. Let's refresh. Hey, yeah, there we go. So this is great and all. We've got a running web server. It has no relation whatsoever with our other two containers, the other two services, which is backend DB. It doesn't even have any relation to our React app we just built. So let's do that. So go over back to our Docker file. So what we're doing here is, you remember this particular location that I showed you just now? So it has two files in there, right? It had a 50x.html, this one here, and then it had an index.html. So this particular line, what it's doing is that take the entire contents of this build folder and automatically port it over to, and we overwrite whatever you find at this location. All right.
Why this particular Docker file don't need to specify the working directory? Backend one need to specify working directory.
Great question. Because right after the working directory, I need to run this particular command. This particular command requires, it will automatically look for a package.json file. If you didn't specify the work there, you are not changing the CD, the cursor inside the build, and therefore it's not given an opportunity to get to the correct position and npm install.
Sorry, I think I missed out this one. Line 6. Expose 3000. What is this for?
No, not you. Okay. So when you run docker ps-a, the stuff on the right that appears is the result of your expose. So let's say, for example, you are working with Postgres, and if you were to go to this one, and you were to go to, let's say we're using 13.3 Alpine, let's say you click on this one, look into the Docker file. Oh, awesome. Look through and you look for an expose line. So that expose line is it's like your way of telling Docker, when you up this container, be ready to expose this port. This port is exposed. It's like a signal to the outside world that this is like an output that people are supposed to connect their cable to.
Sorry. So in continuation to that, like in the Docker Compose, we'll have to like attach it to 3000 in our Docker Compose YAML.
That's the tip off that you get when you read the Docker file. Always wonder, we place so much emphasis on the number on the left, but what about the number on the right? How did I divine it from thin air? I didn't divine it. I just looked at the Docker file or look at the instructions of the Docker image that I'm using, and they will tell you what ports to use.
Got it. So the left is up to us when we are running locally, but then the right is set by the image.
Correct. It's set to you and what you have available on your. So in my work project, right, it's common for us to run multiple Spring Boot applications. So the default Spring Boot port is 8080, but then if you're running 3 different Spring Boot applications, 8080 is busy, right? You can't, so that means 8080, 8089, 8090, 80 port 7000. So you have to vary your ports depending on what available.
Why the content from the build folder in the host is different from the one in the nginx?
Nginx. Why the content is different? Because we haven't built it yet. We haven't made use of this Docker file yet.
Oh, okay. Alright.
Yeah, this was just me showing you what a default Nginx web server looks like. Okay, so now let's make use of our friend here. There is one last file which I'm intentionally omitting now because I want to naively walk you guys into the problem. Okay, so let's do that. So let's cd out of this guy, cd into our sample React app. Make sure it's there. Make sure the Docker file is there. Okay, grid suite. So now let's build Docker. You guys should be veterans at this already by now. Docker build. Let's give it a tag called sample web sample React app. Let's call it latest. Given the very context which I'm in right now, sample React. Okay, go. Wow, that was lightning fast. No npm install. So yeah, we're done. So let's verify. Docker image ls IC at the very top. My node app version latest. My node app sample React app. What did I use? Dash Docker build dash t sample React app latest. Okay, what? What did you not show? Cat Docker file. Yeah, looks good. And okay, let's try again. Sample React app latest. I think image that's see what? Okay, what? Oh, I know why. Maybe it just didn't detect any changes. But can't be what? Okay. Docker image ls. Okay, I'll tell you what. I'm going to delete this image. Oh, I haven't shown you all the command for delete, right? It's easy peasy lah once you figure it out. So Docker image rm this one deleted. Okay, so I also have a little nifty little alias that will remove all these none images. We remove all none. So I also have another alias for listing all images. So di. So I have no sample React app now. Let's build it again. Okay, di sample React app repository sample React app latest 9 hours ago. Huh. Let's use that. Okay, let's just use different name, guys. Let's just sample React. Sample React. There we go. Sample React 9 hours ago. I think I know why, guys. Because the contents are the exact same. Oh yeah. I did this the exact same. Yeah. So that's why. Okay, so let's use it. Okay, so this is a good teaching moment. So Docker has some optimization built in. So if it realizes that the layer that you just built is the exact same, it caches it. It caches every unique layer that is ever built, such that when it detects no changes, it will use the version from the cache. So since what we've done is not much, we just npx create React app and then whatever it is without touching the code at all. So Docker detected that there's nothing that has changed. So that's why I say that it didn't build a new image. It's the same one that I did nine hours ago. So that's what's happening here. So let's go back to our Docker compose. Paste this sample React latest. So now I'm not using the base image anymore. I am using our own custom image. So that's what's happening here. Okay, so DC Docker compose. Okay, Docker compose down. Oh, I know why. I made
Why
the
you
color.
interrupt this process?
Doesn't matter. As in the container
Right.
does fail to run, then it will still exist. So that means this is king. This command is always king. This will list you docker ps-a. -a will list you all running containers on your pod, on your computer. Hey guys, give me a sec. Let me just plug in my. Sorry, there was a question.
So it's like this Docker thing a way to provide a common like web server and database for everyone to use.
Yes. So if you're working on let's say a team of developers, right? And every day when you start your day, or you're on board a new developer and they have a fresh machine, you don't want to go to the trouble of okay, first you install Postgres on your host machine, then you install Node.js, then you install it's a pain in the ass. So what you do instead here is you check in into your repository, the Docker Compose YAML file, and then in your README you just tell them, okay, to get started developing, just Docker Compose up-d. Then boom, the Docker Compose YAML will encapsulate everything that the entire development environment that the guy needs. That's the magic. So where were we? Okay, so let's Docker Compose up. So fresh slate, there's no running containers. Docker Compose up -d detached. Okay, so we've learned Docker Compose logs -f Let's see the logs. Let's expand this. Web has successfully started. Backend has successfully started. Sync to 3000. So let's begin. Because refresh, I get my React app. Ta-da! And if I were to make changes to the Docker Compose is pretty smart. So it detects changes and knows exactly what to up and what to down. So let's demo that. If I were to not expose 80, maybe I want to expose port 7000. Just because I want to be fancy. So I can just Docker Compose up again, and it will detect that. You saw that? Did you guys see that? So you saw that it is only recreating web. The other two guys, we're still good. So the other two guys were up to date. So ignore. So that's what's happening here. So on 7000. So now if I press refresh one, it will no longer work because it's not nothing is listening to port 80 of my localhost. Okay. So here comes the last part. What is left is actually more pertinent. Is less pertinent to Docker and more pertinent to how to configure web servers such that your front end React router stuff can work. Not really.
Or is it pointing the wildcard to
Yeah,
the
start out. So essentially, that's the last line. Remember this guy, the one that we omitted so far. So if you just eyeball the contents of that Nginx configuration, right, there is this last line here that you need to have. You need to have this block here. This block here says that for any access to route, if you were to try files at this position, if you don't have this particular line, yeah. So by default, right, it just looks like this. It just looks like this. But you need the last line to make React routing work. It will take me another 20 minutes if I were to go through it. So what do you guys think? You want me to continue or you want me to just stop here?
It's not related to Docker lah. Yeah.
Yeah,
But
So this is necessary because this is more to Nginx.
Yep.
React.
So if you're good there, then you're good. You're done. Oh, okay. Just the last point. The last point that I just want to make is you wouldn't do this. You wouldn't host your React static app, your SPA, your single page application. You wouldn't host your flat files out of a container because this guy is understandable. This guy will probably need an ability to connect to DB, right? But this guy actually does not need to be in the same Docker Compose even as the other two. So really now, this guy you should really just it's a static file, it's a React app. You should post it on you should be distributing it through a CDN like S3, like AWS S3 even. Or S3 is not a CDN, but it can serve out static content. You should serve your React files out of GitHub pages.
If you do CDN, do you need to modify the router thing? Or I never done it.
Yes. So I've done it. So with GitHub pages, right? With React router, they have three types of routing, right? They have
The
memory
hash.
router for testing. Yeah, hash router for referencing the hash part out of the URL, and the browser router. Browser router won't work with GitHub pages, so I had to use hash router. That's the workaround.
But if you don't want to use hash router, you need to serve it from a server, right?
You need access to the web server, which
Right.
GitHub pages won't let you lah. Yeah. So because they don't expose a place where you to copy over your nginx.com for. So you can't do that then. But then the world, this is not an original problem. The world has already a solution for this. Hash router lah. That's it. Okay, was this tough to absorb?
This is good for me. Yeah, finally understand at least how to get it up and all the different parts of it. Thanks. Appreciate it.
Yeah, I feel a lot of gaps for me.
The final resting state is over here on this particular repo. So there's no sorcery. It's all there. Sample React app, sample, and some bits of it what you saw today could be slightly different. But if you just look at the Docker Compose YAML, it's all there and more of the same. And it is very basic, guys. There are way more advanced things that you can do. So for example, this volumes is I haven't showcased that yet. Yes, I should remove it. So if ever you want to go back and you get lost, you don't know what disciples say at that time, you just refer to this repo lah. And Docker Compose, it's not advisable to use it in production because Docker Compose insists that you'll be deploying your front end, your back end, and your DB all in one server, all in one EC2 instance, which is not best practice. Best practice is to separate your presentation layer from your application layer from your persistence layer. So you need to deploy. That will automatically mean that translates to having to use 3 different EC2s, minimally.
Will cost more also, right?
Will cost more, yes. But it's for the name of security. A lot of things are holy cows.
But for like toy project, it's okay to just host on.
So for a toy project where you don't care about all these things, yeah, go ahead and Docker Compose. In fact, I have a toy project in production that's that's using Docker Compose because keeping it cheap. And if that is the case, if you need to run it in different servers, you doesn't mean that you can't use Docker. You still can. It's just that you got to do the code needs to, instead of just hard coding DB host to resolve for your database, you need to have something else, something resolvable.
So you say that DB is automatically resolved, right? Say if you console log the single code DB, will it print out the DB or will it print out the host name?
If you console log the DB string, you will come out DB. It will not come out the IP address.
But I think when just now you did the OS host name, right, on the server, it actually printed out the host name of the
Yes.
container, right? It
Yes.
didn't. Yeah. So I think maybe that's the closest thing you could get, lah. I don't think you will print out the DNS like resolvable.
Awesome. Okay, this is a good teaching moment. Okay, let's Docker Compose up again. Docker Compose up -d. Let's find it again. 3 DC. Are you guys awake? Okay, great. Another command useful for debugging in production. Docker inspect. So first you list out the targets that you want. So let's say you want to inspect web. Or wait, you want to inspect DB. Okay, that's a good one. Inspect DB. Okay, so copy that. Docker inspect. Come on, inspect this guy. So it will list out for you all the quite gnarly details, but it's there, all that you need. So one of these is hostname. Hostname is somewhere in here. Okay, you know what? I'm lazy, so I'm just gonna do delete. Go away. Where you? Okay, you go away. This one, grab, host. There you go. Hostname. Ta-da! Host
That's
port.
just the container name, no?
Uh,
The one there, Docker inspect, blah blah blah.
Okay, we can test this. So remember, just so happened that my backend is list out the host name, right? So we can test this real quick. So port 3000, localhost 3000. So localhost 3000. Okay. What is the host name? 544 FB. Okay, so let's inspect that particular container. Docker backend is here. Docker.
Then you just highlighted it. It says the 544 MB.
Oh yeah. No, but I want to see host. No, salah.
Crap.
There you go. Yeah. Yeah, it's the host name is the image. Yes. But the DNS, you want the DNS, is it?
The DS is like resolved everywhere or it's just at that part?
DB, you mean? DB? It is a domain. It is a domain that only exists inside the Docker Compose. So, for example, if you had some code that is inside web, for example, and it will try to resolve a URL host backend, then you will find you'll find this container.
So inside the server.js, like we need to be careful not to use that single code DB for like elsewhere.
No, it's fine. No, it's fine. It's like it's like referencing localhost, like when so you are giving this creating this new client, right? And then you are giving the parameters to connect to the DB and the host name normally you would put localhost because you have your database running locally, right? But instead of running locally, it's running within the Docker network. Could you actually put the Docker image, the host name actually, the whole hash number thing?
You know, never tried. But this won't work. If you type localhost, this won't work because localhost in a Docker Compose setting, localhost refers to that container's localhost. This will not work in a Docker Compose setting.
Does that mean you cannot call the service localhost? So?
Probably. You probably could. I don't think you'll fail. I think they will allow. It's just that you'll get weirdness. Localhost is essentially all computers know as the loopback, right? 127.0.0.1.
Anyway, I think to address Wymin's question, right, most important thing is like the DB is not a variable or anything. It's just a literal hard-coded string. And then it's just that the client will refer to this DB as a string and then they know what to do with it.
So if in the next line, right, Wymin, if you were to do log the DB, it's fine. It's fine. They will literally just
print out the string.
They'll print out the string. It is only sensitive in this location because this has special significance. You are passing to this particular library. You're passing to this particular library the connection string where the host is whatever that host name is. It's not like because you use DB then forever and ever you cannot use the string DB.
What does it mean to deploy this app to production? So like example, you have an AC2 instance So you upload everything, configure everything is all okay. Then so meaning you deploy it, meaning you just run Docker Compose up and then it's deployed. Is that what it means?
If it's you're going for a single instance deployment, you're okay
Yeah.
with all services being on the same computer,
Yeah.
being on the same server. Yeah, that's what I mean. So the only thing that you need to install is, say you up your EC2 or you up your DigitalOcean droplet, and then you do all the normal security stuff, the hardening stuff. Then after that, the last dependency that you need to install is Docker itself. You need to install Docker at your server, and then in the world of Linux also Docker Compose is a separate install. So you also need to install Docker Compose. Then you just need to copy over the contents of this file. Copy over here. Okay, so but you got to make sure that the images that your Docker Compose uses are reachable from your production server. That's the key point. So all these images, right, like Postgres, they are reachable because they are available on Docker Hub, which is publicly available. So if your EC2 instance has access to the internet, yes, it can find its way to Docker Hub and retrieve the Postgres base image. But MyNode app and Sample React, these are our own custom images, right? So that means these guys are not. You won't find this. You won't find our app, MyNode app, on Docker Hub. You won't find Sample React on Docker Hub because it only exists in our dev machine right now. Because that's where you build the image. It only exists on our dev machine. Okay. So what then, right? What's available to you? So that's where container registries exist. Private container registries exist. So let's say you've already built your image and you don't want it to be available to all and sundry. You want it to be just available to you and your team. So private Docker repositories are the way to go. So we've learned earlier today during the MSOCIETY infra session that GitLab.com has a Docker repository, Docker image repository for free. AWS has its own ECR service, Elastic Container Registry service. So you run some command line, you can push your local image, the image that exists in your local Docker, you can push it to the repository. And then over at your production server, you need to install the same AWS CLI so that you can pull the image from that repository. You understand? So that's the handoff lah. That's the handoff between your dev machine and your. So you build your dev machine does the work of a manual, like a human run CI server, continuous integration server. It builds the image and then pushes it to some remote image repository, and then over at your destination you would pull it. This is a very low tech way of going to production, a Dockerized application.
So meaning it's just to run, make sure it runs on that instance lah. So that means that is already deployed lah. Is
Yeah,
that
that's what it means.
Okay.
That's what it means to go to deploy something to production.
Just make it run on that instance lah. Then okay.
Correct. So on the instance, it will expose two ports. For this rudimentary application that we just went through in this bookshop, you will expose port 8080 for your web if you're serving your React app via the same EC2, and you will also expose port 3000 because once the React app is on users' browsers, they will make API calls. They will make API calls to this EC2 at port 3000 so that they can get the Node app REST API. So you will not expose this. This you will not do. This is the key point, by the way, guys. This will still work. If you delete this, this will still work. And it is the preferred way to do it. It is the secure way to do it. Because database, you don't want to expose to the outside world. Because it don't care, right? The only one that should care about talking to the database is your backend application. So you should not expose the port onto your server. Follow? This will still work, This will still work. This server, because when in the server code, you are referencing DB, and DB is accessible because they are part of the same Docker Compose network. So this guy can still find DB even though you didn't expose the port. Was that a lot?
Wait, if we do that, then is it still possible for us to access the database?
You can't. So
Oh,
because
okay.
I expose, so that means on my this one on this screen, right, on this GUI, when I try to access it for Apache 5, since it's already been deleted, right? So this line no longer exists, right? So if I have to do this, I cannot hit it. Cannot connect to it, which is a good thing in production because you don't want people to just simply port scan your EC2 and then try luck with passwords.
Then, do you do that in your work? Like,
We
remove
lock it behind a VPN. So
okay.
we lock it behind a VPN. So at least there's some layer of security. But even then, also the authentication, let's say for example the username and the password, right? We use AWS simple token service, so it will generate short-lived tokens. So each token generator can last for maybe 8 hours, and after it expires, then you have to generate a new one.
Understood. Yeah, because we do sometimes need to get into our production database to debug or stuff like that. Okay.
So for us, 2 levels of defense are you need to be connected to the VPN, and you need to be able to generate the vault to be able to run the vault commands. We use Vault. It's a secrets manager by HashiCorp. So you need to have the vault access to be able to generate your short-lived token. So that's like at least 2 points. That's at least 3 points of defense. Yeah, at least 3 points of defense. Yeah, that's it. That's it, guys.
Yay. Thanks for the workshop.
No worries.
So far, my experience with Docker is very patchwork lah. Like as I need kind of thing, I just look it up and then follow the tutorial, follow the guides and whatnot, right? But I don't understand like even all the commands, like describe it step by step, like the Docker image, Docker volume, Docker PS, right? Even something simple like that, or like now kind of makes more sense. Because like my experience with Docker is just literally how to Dockerize React app, how to Dockerize Next.js app.
So
copy paste.
it's one of the revolutionary things for me is the moment I realized that there is Docker Hub and this entire universe of useful applications already Dockerized, right? You start thinking, is there a Docker container for WordPress? Is there a Docker image for Strapi? Is there a Docker image for everything under the sun? So back then, so let's look. And then if you don't want to self-install, because WordPress is a PHP application, right? So if you were to run it locally on your machine, you want to build some dev work, right? You're gonna need to install PHP, you need to install a web server, you need to install this and that. But with the advent of Docker, you literally just Docker pull WordPress and Docker run WordPress. You got a fully running WordPress in one command. Yeah. So CVCRM, that's something that's can be used as well. For Drupal, you want to write your own CVs, right? I recently had to do for work traffic. It's a reverse proxy as well as load balancer that I use for my project. Need a reverse proxy, there you go. It's available. And if you have business process routing, let's say you have BPMN, business process modeling and notation diagrams that you need. Pokemon then there you go. Yeah, it's already there. Yep. Revolutionary. Halik over at UK, how are you?
Yep. Hello. Sorry.
Can you follow? Waalaikumsalam. Can you follow?
Yeah, I could follow. Thanks very much. Yeah, this is like one of the few times I typed Docker in my life, so just following. Yeah.
But it's very hard, yeah. I mean, I try not to use it. Also, the versioning also, right? Is when you use the official image, it's best to use a specific version, right?
Yes. I was gonna say that. Friends don't let friends use latest.
Yeah, because in my work, so the latest package changed the base Node version or something, or base Linux version, and then it didn't have a specific command in that one, and then everything breaks. We even found the exact issue that they suggested, the exact PR they suggested to change.
Yeah, friends. Okay, this is a very good teaching moment because when you go on Stack Overflow and you get examples, you will see a lot of people just lazily use latest. You don't generally want to go to production with this. You want to freeze it because let's look at Postgres on Docker Hub. Okay, latest is equivalent to 13.3. But a year from now, latest can be something else. So if you just keep referencing latest, which is a default word in the world of Docker, it's a moving target. If it's a major version upgrade and your infrastructure is not ready for it, or your compliance hasn't hardened it and all that, then you're in a world of hurt. So don't use latest when you're going to production. Always use specific version. So that's why for base images, I always take special care to name specific version. So even my Nginx, I name specific versions because I don't want it to move. So testing is important, kids. Very important.
My experience also, even if you change the version also, there's still a slim chance, right? Your test cases will pass, right? But on production, right, they still get like some unexpected result.
That means that every bug will happen exactly once. Once you've discovered the bug, you write a test for it. Go ahead. Who's that? Go ahead.
I don't know if my question even makes sense, but I'm just wondering, where does this process fit in your CI/CD pipeline? Is it only at the deployment stage, or is it before that?
All the way through, actually. So the final artifact of my CI, at least for my project at work, the final artifacts of every CI stage is a Docker image build, and it gets pushed to our own self-hosted repository. It's an open source software for hosting your own Docker images.
Docker Hub has private repo, right?
Yes, you can,
Yeah.
but I don't know. Then is you just
That's how we use
YOLO into IMate audit and hope you don't give up on it. Yeah, container orchestration. There you go.
Yeah.
Okay. Jana, I felt like we cut off someone. Who was it? You had a question.
I got my question answered if you're referring to me. Thanks so much.
Anybody else? Closing question? Going once, going twice. All right, that's the end of stand up. Clap.
Yeah.
Okay, thanks. Bye.
All right. Bye bye.
Okay,
Bye-bye.
bye-bye.
Bye. Bye. Thanks.
Bye. Thank you. Bye.